Okay. So let's go over that one more time. So because I'm on the left side and it goes up negative forever, it's going to be negative infinity all the way to -3. Because there's a break in the graph means I have the union here with whatever's going on over here. So again, it's always left to right. So again, it's open. So that means I need an open parenthesis. And from 0, and it goes on forever. So it has to be to positive infinity. Now somebody's going to say, do I have to have the positive? You don't absolutely have to have the positive, but you probably should put it there.
Okay, I had a question. So I did it with like the X, like, and then the sign. So I did like the opposite of like the table, what was on the left side yesterday.
Mm-hmm.
Would that be the wrong answer? So you want us to do like that way then?
Yeah, this is the way that you should do it.
Okay.
Okay. So if you did it something like this, where your x's are less
Yeah.
than -3, and then you've got an or, your x is greater than 0, we really want to get past this. This is more of algebra, algebra 2,
Okay.
and get onto this. So by the way, once you understand this, it's actually going to be a lot easier. But this is how we start to put things for the rest of the year in this. So you have to understand the interval notation. So what other questions do you guys have on that worksheet?
Devin wanted me to let you know that her computer, like her Zoom is updating, so she can't get in yet.
Ah, okay. Yeah, they just made an announcement. Anybody else want to see one from the back? Now we're going to talk about 1 through 6 on the bottom, but does anybody want to see the top 1 through 6?
Yeah, can you show me five, please?
And I show you number 5.
Yeah, because it didn't have any circles, so I didn't really know.
Oh, perfect. So if it doesn't have any circles and it's arrow on the left and arrow on the right, what do you think it's going to be?
Negative infinity and positive
Yeah.
infinity.
That's exactly right. So it's all real numbers, which is negative infinity to positive infinity. Now, number 6, oh boy. Number 6, let's make sense of this before we do anything. So to me, it goes left forever, has a soft stop at 2, then it goes right forever, soft stop at 2. Another way to say this is absolutely everything except for 2. So what in the world did I just do? That was weird. So what that should look like is something like this. And I think it was 2 that was open, right? So again, there is a break in the graph because it goes this way with an open circle and it goes this way. So I'm going to have a union. I didn't mean to make it like that. I'm going to have a union. So everything on the left side goes left forever. So negative infinity, and it stops at 2, a soft stop. Yeah, a soft stop. Then the right side, so now I'm looking at it only on this side, starts at 2 and it goes on forever. So positive infinity. So anytime that there's a break in the graph or it goes 2 different ways, you're going to have a union. Oh, you're okay, Lauren. Everybody, including myself, we're all having. In fact, last period, my Active Inspire crashed, so it took like 3 minutes to reload. All right, any other questions on the assignment? We will look at the last 6. I'm not promising we'll do all of the last 6, but we'll look at it.
Number 4 on the back.
So number 4 on the back. So again, -4, +4 going both ways. And was it open or closed on both of them? I think it was open.
It's open.
Yeah. So again, anytime there's a break in the graph or it goes both directions here, left side, it's open, so I need a parenthesis. On this one here, again, left side here, and it's going on forever, and that's it. Now, this really is important that you guys get this. Any questions? All right, because we've got more to do today, and we're going to use some of that, let's go ahead and do a couple from the bottom. And you guys can see this, right?
Yeah.
All right, so this is going to be a lot harder for me to do on here. I wish I could write straight on this. But name the domain in the range of each. Well, if you guys can kind of see my mouse here, the domain, remember, we're looking straight left to straight right. So all the way from here, it is continuous, and I'm just looking left to right, so it is continuous all the way across. There's no breaks in the graph anywhere. So my domain starts with an arrow and it ends at an arrow, so my domain is all real numbers. Again, how do I write all real numbers?
Negative.
Yeah, tell me, how do I do that? It should be negative infinity to positive infinity. Now, my range, remember, my range is always from low to high. Well, I start low and I see an arrow. That means that's going to keep going forever. There's no breaks in the graph as I go up, and I end at an arrow, so that is also going to be all real numbers. Now, I don't like number 2 because it's making an assumption here on number 2. However you put this is fine. Some people saw it as an arrow, some thought it was a hard stop. Either way, let's actually treat it like it's a hard stop, because if it's an arrow, it should be an arrow. So my domain is pretty simple. My domain on the left, we'll consider these a hard stop, but my domain is going to be all the way from -10 with a bracket to +10. My range is going to be whatever y value this is, which I can't see. Is that -3, -4? Looks like -3. Remember, your range goes from low to high, so -3 all the way up to +3. Again, bracket on both of them. So when your range, you're talking about your range, it's low to high. Your domain is left to right every single time. Hey, Devin, you made it. Woohoo!
Wait, why is it a hard stop?
Well, so it depends on how you saw this. I don't like leaving anything up to your imagination or for you guys to guess. But if I don't see an arrow, I don't want you to assume anything. So I'm actually gonna just for sake of helping you guys out here and teaching it. If I don't see an arrow, there's not an arrow. That means it's a hard stop at -10. Now the difference between a hard stop and a negative stop, a soft stop, yeah, is the difference between an open circle and a closed. So unless they specifically show you an open circle or an arrow, we consider it a hard stop. Again, my range on this was -3 was the lowest, and it looks like +3 is the highest. So bracket -3, comma, +3, bracket.
So is the range like where it like crosses that point at? Like crosses the points or what?
Okay.
I'm confused. Like, how do you know like if it's a real number or like the range on it?
All right. So we've got something like this, and I'll just say like -10, +10. So And they should have really put that in there. If we do something like this, right? With your domain, you're always just looking in this direction. So hard stop left, it's continuous all the way through. Hard stop right, so that's your domain, okay? Now your range, you've got to look at it differently. Your range is always going to be this direction to this direction, always low to high. So it's continuous. So hard stop at -3, it's continuous all the way up, going up. Hard stop at +3, so my range has to be -3 to +3. That makes sense? So your range, you're looking from low to high. Your domain, you're looking from left to right.
Will it always be like the opposite number then? Like,
No. So that's a good question, and I'm actually glad you noticed that pattern, but no. So let's look, for instance, at number 4. Okay, so I've got -4, 6, and -2, 7. And let's see what that looked like again. Saw stop. All right. So again, my domain, I'm going left to right. So really, you guys can see left is going to be -4 and the right is +6. So, and it's open, so it's soft, which means parenthesis. My domain is going to be from -4 continuous all the way till I get to 6. It's an open circle, so it's open. Does that part make sense, or does anybody need that re-explained?
So if there's an open circle, it's going to be a parentheses, but if it's a
Yeah.
closed circle, there's going to be a bracket.
Exactly. Perfect, Evan.
The infinity sign come into that.
So infinity just means if I had an arrow here instead of that, now my left side would be -infinity. And does infinity ever stop? No. So I'm sure everybody at some point has played that game like, I love you infinity. Well, I love you infinity +1. Well, I love you infinity plus infinity. You can keep one-upping it. You can go a step past that. So that always, whenever you have infinity, it's going to be a soft stop because it really doesn't stop.
So for like on the same page, if we could go back up to number 2 at the top of the page.
Yep.
So for that, would it be like infinity since there's an arrow?
So number 2 at the top of the page. So you're talking, are you talking about like that number 2?
Yeah, that number 2, not where it's
Yeah.
that.
So that number 2, you would write that as -infinity with a parenthesis, and then on the right side it stops at -5 parenthesis.
Okay, I think I'm getting the hang of it now.
All right. And again, I just think you guys need a couple days of practice with this. We're going to add a little more to it today, and then we'll kind of slow down a little bit tomorrow and do the homework check. All right. So let's finish this one, number 4, and we'll look at one more time. So your domain, you always want to think about this as from left to right. So my smallest value here is at -4. It's continuous. There's no breaks. And my biggest value is 6. So all I need is from -4 to 6 with parentheses. Now my range, remember your range is from your smallest value to your highest value. So my smallest value is -2 and it's open. My highest value is +7 and it's open. Any questions?
oh, so you're always going from the lowest number with the range then.
Always. And in fact, Larry, I'm glad you said that because it's always, left side is always on here. It's always the lowest. So it's always low to high. Now, some people that might confuse even more. But again, notice low to high on your x's is still, it's left to right, but it's your lowest number to your biggest number. It would not make any sense to do this. That to me doesn't make any sense. It has to be in the correct order, left to right.
Okay. I got you.
Okay? And lowest to highest. Other questions? So let's do number 6 real quick. If you get number 6, you should be pretty good with all of these. So let's see, I got -5, 7, and is that -6 and 8? Let me look one more time here. Yeah, got it. Oh, circles. And then, sorry, what was it? Right on the right side, ending it just over that. If you get this one, you're exactly where you need to be. So with your domain, again, I'm just looking left to right and seeing if there's any breaks in the graph. So my domain goes from -5 to 7. It's open. There you go. Now, with my range, and I'm going to do something else real quick. With my range, I'm going to get out a straight line here, and I'm going to move this just a little bit. So, by the way, my range, and that was supposed to actually hit -6. So let's say it hits -6 right here. Do I see any indicators showing me that that's open? Kind of a rhetorical question. There's no open dot, so it actually hits the lowest value we have here is -6. Oh, but wait a minute, what'd I do wrong?
Should it be a bracket?
Why, Caroline?
Because it actually hits it.
Exactly. So unless I clearly give you an indicator that it's open, that means that this actually hits -6. Now,
Wait, okay, I think I might have a stupid question. What if you can't tell, what if you can't tell if it hits it or not? What if there isn't a clear indicator, but you can't tell?
It has to have a clear indicator, which means unless this would have come here with an open circle, and now, yeah, and now it would be the same type of thing, okay? Now it would be a parenthesis. Because I don't see an open circle, that means they just either they didn't give me enough information or it's saying that it hits that, okay? Now, your range, the lowest it gets is -6. Remember, we're not looking left to right, we're looking top to bottom. So if I keep going, it's continuous, continuous, continuous. I do not care that right there, it ends on the right side. It doesn't matter at all. Because I'm talking about one graph, it does not end until we get to 8. And it's open, so it is going to be to +8, and it is open, so I need a parenthesis. Any questions?
All right, wait. Can you explain one more time why it's a bracket for 6?
So yeah, so a bracket at -6, because unless they specifically tell me that it's open by putting a circle, unless they have specifically told me that it's open, when this goes down, remember, this is going down all the way, and at right there, it actually hits that point. So we could call that point like 4, -6. So that's just an ordered pair. If it actually hits that point, then that's why it needs that bracket. Okay? Writing that ordered pair there might have actually confused more people. But it's going to hit this, and we kind of work under the assumption that unless they show us an open circle, then they are showing us that it actually hits that value. Now, let's go ahead. We don't have a ton of time left in this class, so we've only got about 15 minutes left. So let's go ahead and take some notes. We got to move on, and then we'll kind of slow down a little bit tomorrow. The bad news is, great. Like I said, my computer crashed last period. So now I got to go through and look at all of these. No, not that one. That was yesterday's. This is it. All right. So a function, it's a relation that maps one input to only one output. The exact math term is this: each x has exactly one y. Each input has exactly one output. And some people are saying, well, what does that mean? Here's a perfect example. Imagine the confusion. If, for instance, you go to a pop machine and you press Coke, but you don't know if you press one button, one input with the Coke has multiple outputs. If I press that button, I should get a Coke. If I press that button, I can get a Coke or a Sprite. All of a sudden, it doesn't function properly. Same thing with a keyboard. If I press the M button, I should have an M on the screen. So that button gives me one value, the M. If that button has multiple keys, well, all of a sudden, it doesn't function. I'm sure that you guys are way too young, but did anybody actually have one of those T9 texting phones? Did anybody have one of those? So talk about not functioning. You know how it says ABC on the 2 button and then DEF on the 3 button? Well, you had to press it. If you wanted the A, you'd have to press 2 once. If you wanted the B, you'd have to press 2 twice. If you wanted the C, you'd have to press 2 3 times. That is not a function because that one button had 3 different options. So that's what a function is. Each input has exactly one output. Now we talked about the domain and the range. So let's move on. By the way, these notes are already up on Canvas. Determine if it's a function, and we're going to go kind of quick. I do not care about the y's at all. Y's don't mean anything if it's a function, which means you guys have all seen this. There's a pop machine where it's nothing but Coke. So every single input there's 10 different buttons, but the output's all Coke, especially if you're at like Kings Island. So what's my domain? Is it a function? My domain is 1, 2, 3, 4. The x's don't repeat, so is it a function? Yes. Why? Because my x's don't repeat. On B, I see 6, 6. I can stop right there. Is it a function? No. Why? Because this 6 gives me a 5. This 6 gives me a 1. Not a function. Questions? Next one. So for an equation, if 2 or more values of y can be found for a given x, it is not a function. All you really have to do is solve for y. Now, when I solve for y, if I plug in any value like 0 or 1 or 2, it's going to give me a specific value, only one value. If I plug in 0, it gives me 4. If I plug in 1, it gives me 5. If I plug in 2, it gives me 8. So on and so forth. Each input has exactly one output. Now I'm going to give you guys a heads up here in just a second. You're going to say, well, when would it not be a function? If I solve for y, how do I solve for y? How do I get rid of this exponent? By taking the what?
Square root.
Now, anytime you solve by taking the square root, remember, I have to account for positive and negative. So think about this. If I plug in any number here, now I have multiple solutions. Why? Because I have both the positive and the negative. So for the most part, that's all that is. So it will never be a function if you're solving by taking the square root. So if you ever have a y squared, that all of a sudden means that it's not going to be a function. By the way, if I were to graph this, this would actually be a circle with a radius of 2, and it's not a function because look, a function, each x has exactly one y. Well, the vertical line test, again, you guys saw that in algebra, you saw it in pre-algebra, you saw it in algebra 2. This is a reminder. Speaking of the vertical line test, if I give you a graph, if I can ever at any point draw a straight line, a vertical line, and it touches the graph in more than one place, it is not a function. Again, know that some of you guys are writing this down. This should all be a review, albeit a very quick one. So be careful, mind your open and closed. So what just happened? Ugh, are you kidding me? There, no. Ugh. This is annoying. I'm sorry, guys. I think it was the other way. There it is. All right, so again, what this is saying is that no vertical line, and people are looking right here. Well, does this touch it twice? No, because that's open, which means it doesn't hit it there, but it does hit it here. So yes, this is a function because it's open and closed. If they were both closed, not a function. Now, if I say determine the domain and the range, well, we already did this yesterday, but the domain is 1, 2, 3, and 8. And I could, if it's discrete like this, if they are set points, then my domain is just 1, 2, 3, 4. My range is just the y's, which would be 6, 4, 8, and 9. Any questions? But on B, it's different. The domain and range is different because it's a continuous graph. Anytime you are writing your domain and range on a continuous graph, use interval notation. Right, interval notation means my domain, I've got a arrow and an arrow, so my domain is what?
Negative infinity, infinity.
That's exactly right. All real numbers, negative infinity to positive infinity. My range is low to high. Again, here's that situation. So should that be a bracket or a parenthesis?
Bracket.
Bracket.
A bracket. Because unless it showed me that the lowest value it is -2 and it goes up forever, there you go. Questions?
It was a bracket because it didn't have a open circle, right?
Exactly. So in math, we don't ever really work with assumptions, but sometimes we do. This is one of those things, unless they clearly show me, then I'm assuming that it actually hits it, okay?
How do you know it's an open circle?
It'll show, so if I wanted an open circle there, they'd have to show me like the open circle,
Okay.
okay?
So do you want us to like have it like this everywhere and not use like
Not use inequalities anymore?
yeah.
Yep. This is
Okay.
how we're gonna write it from here on out. Now, you'll actually appreciate that more once you get better at this. Now, if it ever says this, evaluate the function. And I know we're running through a lot of Algebra 2 stuff. By the way, I'm not sure if I told you guys this on the same day. Pre-Cal and Algebra 2, the standards are almost exactly the same. We just start to see stuff differently. So everything you saw in Algebra 2 the whole year, it's all actually fair game that we cover in one semester, and we take it a little bit to the next level. So again, this is kind of a college level class. What this is saying is, in my G function, this is my X value. So all I have to do is plug whatever's right here in for X everywhere I see an X. And then evaluate it. So -2 squared is 4. -10 times -2 is 20. And my value for that is going to be just 21. I got to call a timeout because on the second one, what am I plugging in for X this time? Everything that's in here. So be careful. Here's my G function. Here's my G function. So I'm plugging in X plus 2 everywhere I see an X. So I see it squared, so X plus 2 squared. -10 times X plus 2 minus 3. So whatever you see next to the function is what is replacing the variable. Now be careful, because this is not X squared plus 4. What do you have to do with this?
Square root.
We're not solving, so we're simplifying. Boil it out. Now again, I know I'm going kind of fast right now. We'll slow down a little bit before we add too much. So X squared plus 4X plus 4 minus 10X. Combine your like terms. So when I replace X with the quantity of X plus 2, that's what I get. Let me see the next slide real quick. We might actually be done. Let me check your homework. Yeah, I think we can be done for right now. We'll pick this up tomorrow. So real quick, let's pull up your Canvas page. So tonight you guys have an assignment. It's only 1, 2, 3, 4, 5, 6, 7, 8. So it's pretty simple. Determine whether it's a function or not, yes or no. Explain your reasoning. So you got 11, 13, 15. Ooh, 15, I'm sure there will be questions, but you'll be fine. All right, we'll talk about it. But that's your entire assignment. So you've only got like 8 questions, and you've got number 7 and number 9. All right, domain and range. That's it. If you have questions, let me know. Other than that, we are finished for today.